Alright, welcome to AP Calc. You are either here because you absolutely love math or because you just want the college credits. Either way, we are going to learn about how to take the derivatives of inverse functions today by doing this lovely word problem that I'm sure you're really enthusiastic to do. So, I'm going to start by reading it. It says a patrol car is parked 50 feet from a long warehouse. The revolving light on top of the car turns at a rate of 30 revolutions per minute. Now write theta as a function of x. How fast is the light beam moving along the wall when the beam makes an angle of 45 degrees with the line perpendicular from the light to the wall? Now that seems like a lot, but we're going to break it down nice and easy. We're going to start with step 1, writing down the given. Nice and easy. They gave us the picture right there. It's in the book, which you might not know, but it is. So as you can see, this is my lovely police car, and it is 50 feet from this wall. And this is the angle that the light is making with the wall. That is theta. Now they also gave us that at this point in time that we're trying to find the speed that the light's moving on the wall, the theta is 45 degrees. Now you might think, okay, why didn't you just put that as 45 degrees? It's because it's changing. It's not constant. So you're not allowed to put it there, okay? Now also they gave us d theta dt. That's the speed the light is moving, which is 30 revolutions per minute. Now you might think, awesome, I have d theta dt. You're wrong, you actually don't, because you're not allowed to use revolutions in calculus. Why? I don't know, but you're not. So you have to change it into radians. Now how do we do that? We multiply by 2 pi. So you're going to take 30. You're going to multiply it by 2 pi and you're going to get 60 pi. So officially, your new d theta dt is 60 pi radians per minute. So officially we finished step 1. Yes, lovely student. How can I help you?
Can you please explain to me how the cow ate the cabbage?
No, I cannot. I'm too focused. I will explain it to you later, all right? Okay. All right, so step 2, we're going to pick our equation. So as you can see, there's no hypotenuse up there. So you're going to use tangent, okay? No hypotenuse. So your equation is going to be tangent theta. That's going to be opposite over adjacent. That's going to be x over 50. Now again, you think, yes, got my equation. No, you don't. You actually don't. You have to put it in terms of theta, because that's what the problem wants. So you have to change your equation. That's going to be theta equals arctangent x over 50. Now you have your equation, so we can move along. All right, on over here, we're going to start solving. We're going to take our derivative. Yeah, that's awesome. Now see, but you need the formula for the derivative of arctangent. That is going to be arctangent equals u prime over 1 plus u. So you got that. So you're going to start. You're going to take the derivative of theta. The derivative of theta is just d theta dt. Now you're going to take the derivative of arctangent x over 50. That's going to be 1 over 50, which is the u prime part, and 1 plus x squared over 50 squared. Now this right here, the dx dt, is kicking out an implicit. Because there is an x involved, you have to kick out the implicit. You just do. It's a rule. Learn it, remember it. All right, so step 4, we're going to start plugging in. And you might think, all right, I don't have an x. That's a problem. I should maybe find an x. So we're going to come back on over here. You're going to see this is a 45, 45, 90 triangle. That's amazing because that means you don't have to do any work. It's really easy because since that's a 45, 45, 90 triangle, that means that this is 50, this is also 50. Yay, you have your x. All right, moving back. We're going to plug in now. So you're going to plug in. You have your 60 RPM for your d theta dt that they gave you at the beginning. And then you're going to plug in for your x, and you have 1 over 50 all over 1 plus 50 squared over 50 squared. And don't forget your dx dt. That's really bad if you forget your dx dt. That's what you're solving for. Don't forget it. Keep it there. All right. Finally, we're getting down to the end, guys. We're almost there. We're going to simplify and we're going to solve. Okay, so we have this equation, the same one before. 60 RPM equals 1 over 50 all over 1 plus 50 squared over 50 squared. Now, this, it's the same over the same. What does that do? Crosses out, equals 1. That's really awesome because it makes it that much easier. So you're going to get this equation now. 1 over 50 all over 2. Now, if you don't know this rule, it's complex fractions. You can just bring this 2 on up and multiply it. So then you have 1 fraction. Nice and easy. Not a lot of numbers to deal with. And again, don't forget your dxdt. Just hold on to it. Okay, finally, so you got 60 RPM and equals 1 over 100 times dxdt. You're still trying to find dxdt. That is your goal. That is your speed along the wall. That's what you're trying to find. So you're going to bring that 100 over. You're going to multiply it. So it's going to be 6,000 RPM. And finally, you're there. You made it through the problem. You found your dxdt. All right, so let's see. Taylor, how did you do on this problem? Did you follow it?
I'd say so.
Good job. Good job.
How did I do?
You did. You might want to stay after class and we'll work on this.
Okay.
All right, have a nice day.